curious minds. Welcome back to ProjexCellence ProDigy, your one-stop destination for engaging project management topics. Today, we are adding a new chapter to our journey with a fresh series called Evergreen Mechanical. In this series, we will explore the fundamentals of mechanical engineering and connect them to real-life examples. You know me well. I am Govind, a PMP certified professional and a mechanical engineer with over 25 years of work experience in power plants and the utility sector. Why is mechanical engineering considered an evergreen trade? Let me share my story with you. After finishing my 12th grade exams in year 1996, I appeared for a state level entrance exam for diploma engineering. And based on my rank, I was allotted mechanical engineering. At that time, electronics engineering was the most popular branch, and many of my friends had already taken electronics. Honestly, I felt a little disappointed. I thought maybe I should have gone with the trend. But when my classes started, my professors and seniors changed my perspective. They explained something very important. They told mechanical engineering is the backbone of all industries. No matter how technology changes, mechanical fundamentals will always be relevant. Slowly, my thinking changed. Mechanical engineering started fascinating me even more because it is strongly connected to physics. That was one of my favorite subjects in school. During my diploma engineering, I studied hard and consistently secured the top position in my batch. After that, I completed my BTech in mechanical engineering. Later, I pursued an MBA, earned my PMP certification, and also completed a postgraduate program in project management. I truly believe learning never stops. Education doesn't end with a degree. We must continuously update ourselves with new knowledge and industry trends. My career began in the utilities and power plant sector. I worked with essential systems like gensets, air compressors, water treatment plants, and HVAC system, which is the real backbone of any industrial facility. No matter what a factory manufactures, whether it is a tiny needle or a massive aircraft, every industry relies on power supply, compressed air systems, clean water, and a controlled environment. These are the fundamental requirements of any industry. Just like roti, kapda, or makan are the basic necessities of human life. Now, coming back to today's topic. Why is mechanical engineering considered an evergreen branch? The purpose of discussing this topic is to give a brief introduction to students who are planning to choose mechanical engineering or those who are already pursuing it. The goal is to boost their confidence and help them understand the vast scope and long-term relevance of this field in the future. Motion, heat, materials never go out of demand. Motion means to anything that moves, machines, vehicles, fluids, even mechanism inside a factory or a power plant. Mechanical engineers study the motion through subjects like dynamics, kinematics, and mechanics of machines. Every car engine, wind turbine, or robotic arm involves controlled motion. From conveyor belts in factories to elevators in building and shopping malls, all need mechanisms that move efficiently and safely. Without motion, nothing would operate. Every moving system needs design, analysis, and maintenance. And this is the core work of mechanical engineers. Mechanical engineers deal with thermodynamics, heat transfer, and fluid mechanics to design systems that convert and manage energy effectively. Engines, turbines, boilers, they all convert fuel into useful work. HVAC system, it maintains temperature comfort in building. Refrigeration, air conditioning, heat engines, all revolve around heat management. If we talk about materials, these are the foundation of all physical systems. And mechanical engineers study the subjects like material science and strength of materials, which help them to select the right metals, polymers, or composites for each application. Works across industries, not one trend. Means mechanical engineering knowledge and skills are not limited to one specific industry or trend. They are applicable across multiple sectors, from traditional manufacturing to modern renewable energy. Mechanical engineers are valuable in every era, regardless of changing technologies or market fashions. You might have noticed most branches of engineering, like computer science or electronics, rise and fall with specific market trends. For example, when software and AI are booming, IT engineers are in high demand. And when automation slows down, demands may temporarily dip. But mechanical engineering is not tied to any single industry. It serves as the foundation for almost every type of production, power generation, or infrastructure activity. Field plus desk, strong, stable careers. Mechanical engineering is a blend of field work and desk work. It doesn't restrict you to one environment. You can design a machine on your computer and later see it come to life on site. This mix of practical and analytical experience makes mechanical engineers versatile, grounded, and valuable in every phase of a project. If we talk about field work in mechanical engineering, it means being directly involved in installation, operation, testing, and maintenance of equipment and systems. You see the real challenges that cannot be learned from books. For example, vibrations, leaks, alignment issues, or temperature fluctuations. And desk work is where the analytical and creative part of mechanical engineering happens. For example, designing components using AutoCAD, performing thermal, stress, and flow analysis, working on project planning, scheduling, costing. And when you have both field knowledge and desk expertise, you become highly employable, promotable, and resilient to industry change. Let's talk about the core fundamentals of mechanical engineering. These are the subjects, the backbone, the foundation that build a strong mechanical engineer. If your basics are strong in these areas, your career will always stand strong. Let's understand them one by one. Thermodynamics. This is the study of energy, heat, and work. It explains how energy transforms from one form to another, whether it is an engine, turbine, power plant, refrigeration system, or HVAC. Thermodynamics is working behind the scenes. If you understand thermodynamics, you understand how power is produced and utilized. Second is fluid mechanics. This subject deals with the behavior of liquids and gases, both at rest and in motion. Any system where fluids flow or exerts force depends on fluid mechanics. Pumps, compressors, pipelines, aerodynamics, all are based on this core concept. Strength of materials. This subject teaches us how materials handle forces and stresses without failing. Whenever we design shafts, beams, bridges, frames, or pressure vessels, we must ensure they don't break or deform. That confidence comes from strength of materials. Machine design. Here we learn how to design mechanical components safely and efficiently. Gears, bearings, couplings, engines, mechanism, everything must be designed for performance and reliability. So this is where theory meets practical engineering. Then comes manufacturing processes. This subject explains how raw materials are converted into finished products. Casting, welding, machining, forming, even 3D printing all fall under manufacturing. Because designing something is one thing, but producing it efficiently is another skill altogether. Manufacturing technology, CNC and CAD CAM. This is where computers integrate with manufacturing. CAD helps in design, CAM helps in production planning, and CNC executes precision machining. Robotics, automation, precision components. This is the future ready side of mechanical engineering. Next, material science. This subject teaches us about material structure, composition, and properties. Choosing the right material is critical. Tool steels, composites, special alloys, lightweight materials all require deep understanding of material science. Metrology and instrumentation. This is all about measurement and accuracy. Inspection, calibration, process control, sensors. The quality depends on precise measurement. If you cannot measure correctly, you cannot manufacture correctly. And finally, basic electrical and electronics for mechanical engineers. Today, mechanical engineering is not isolated. Motors, control panels, automation systems, HVAC controls, everything integrates mechanical with electrical concepts. This subject bridges mechanical engineering with modern automation and mechatronics. Now let's talk about the sectors where mechanical engineers can build their careers. The range is massive, and each sector gives you a different platform to apply your core fundamentals. Let's explore them one by one. Power and renewables. I have spent more than 25 years in this industry. I have worked in base load power plants with capacities exceeding 100 megawatt. Plants that run continuously to supply electricity to cities and industries. These facilities are equipped with large bore engines operating on diesel, heavy fuel, and natural gas. And believe me, when such machines run, they are not just engines, they are mechanical masterpieces. Mechanical engineers are the backbone of energy generation. We design and maintain turbines, boilers, engines, wind turbines, and solar mounting structures. From thermal power plants to renewable energy projects, we ensure industries and cities get reliable and sustainable power. Energy drives the world, and mechanical engineers drive energy systems. Oil and gas. This sector deals with piping systems, pumps, compressors, and rotating equipment. From extraction to refining to transportation, mechanical engineers ensure safe and continuous operations. Without this sector, global fuel supply would stop. Third, water and wastewater. Here, engineers design pumps, treatment plants, filtration units, and pipeline networks. We ensure clean drinking water reaches homes and industries, and we protect the environment through proper waste treatment systems. Next, automotive and electric vehicles. Traditionally, mechanical engineers designed engines, drivetrains, suspension systems, and braking systems. Today, the focus is also on electric powertrains and battery cooling systems. From conventional cars to EV innovation, mechanical engineering is at the center of transportation evolution. HVAC and building systems. heating, ventilation, and air conditioning. This sector ensures comfort, air quality, and energy efficiency in homes, offices, hospitals, malls, and industries. If you walk into a building and feel comfortable, think confidently that a mechanical engineer designed that environment. Food and pharmaceutical industry. Mechanical engineers design mixers, conveyors, processing equipment, and hygienic systems. In this sector, precision and cleanliness are critical. We help ensure safe production that meets strict hygiene standards. Then comes materials and metals. This includes casting, forging, heat treatment, and material testing. Mechanical engineers develop stronger, lighter, and more durable materials. And remember, every other engineering sector depends on materials. So this is a foundational industry. And finally, aerospace and logistics. From aerodynamic design to propulsion systems, from lightweight materials to warehouse automation, mechanical engineers help enable safe air travel and efficient global supply chains. So, in simple words, wherever energy flows, wherever machines move, wherever materials are shaped, mechanical engineers are required. And that is why this branch is truly evergreen. If you found value in today's lesson, like, share, and subscribe ProjexCellence ProDigy. Let's keep learning, growing, and engineering a better future together. Namaste, goodbye, Sampai Jumpa.